Hello everyone, welcome back to class, 8th grade math. Hope you had an awesome weekend and you're ready to rock and roll with this math. At this time, do me a favor please, take out paper and pencil, make sure you're ready to take some notes. And I'm going to do you a favor by leaving you a recording of this video for you to view later. But at this time, you may need to take out notebook paper, and a pencil. Ready? Let's go. Real numbers. We talked on Friday about real numbers, and I told you that real numbers break off to either rational or irrational. Rational or irrational numbers. Now, an irrational number are square roots that are not perfect. They do not have a perfect square. So the square root of 2 would not be a perfect square root. The square root of 3 is not a perfect square root. I can't think of any two numbers that I can multiply together that will give me 2. I can't think of any two numbers that I can multiply together that will give me 3. So these are called irrational. We're going to talk a little bit more about pi, and I will be explaining why pi is irrational as well. But you do need to remember that. Rational numbers. I spent some time on Friday explaining that the rational numbers are decimals, fractions, integers. And integers either can be whole numbers and they can be natural numbers. Perfect squares. Perfect squares are also rational numbers. Now, today we want to move into comparing them. And I know you may not have gotten an entire understanding of the difference between rational and irrational, but after you do the homework for this week and then you're in class all week, I promise you, you will be able to have a better understanding of the differences between the two. Now, once you have a clear understanding of the differences, you're going to be ready to compare them. When we compare them, we do that by putting them in order. We can put them in order and then we can tell whether they're greater than or less than or equal to. And in order to do that, we have to use something what we call an approximation. So that means we got to get as close to the answer as possible by finding the nearest or closest decimal of that square root. So we're looking for something called approximations. Now, we can use perfect squares to estimate the values of other square roots. So when we come to a square root that does not have a perfect square, then we've got to estimate. But guess what? All of these are perfect squares right here. Every one of these are perfect squares. You should have a list of perfect squares. The square root of 4 is 2. 2 times 2 is 4. That number times itself will give you 4. Square root of 9 is 3. 3 times 3 is 9. It's a perfect square. Square root of 16 is 4. 4 times 4 is 16. Perfect square. Now, let's look at some that will show you how to compare the two. Again, these are perfect squares again, but we're going to use this information to solve this problem. We're going to use this information to solve this problem. Let's pretend that that symbol right there is not there. Okay, so we're going to pretend that that is not there, but we're going to try to figure out whether this side of the equation or this side of the equation is greater than or less than. I'm going to go ahead and tell you now that this is the answer, but I want to show you why I chose that as the answer. So I need you to pay close attention to everything that I do. Now, this says the square root of 12 plus 6 is less than 12 plus the square root of 6. Let's see why I chose less than. First thing I need to do when I see that square root of 12, I got to think is 12 a perfect square? What two numbers can I multiply together that will give me 12? Nothing. It's not a perfect square. So I've got to get as close to a perfect square as I possibly can in order to solve this. So I'm going to look at the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Well, my number is 12. My square root is 12. So 12 would probably fit anywhere between 9 and 16. Am I correct that a 12 would sit right there between 9 and 16?
Yes, ma'am.
Good. So I'm going to give you some rules with some specific steps on how to find and get as close to them as possible. But for right now, just pay attention that I know that 12 would sit right there in between these. Now, so it must be between this, the 3, and the 4 if we're looking for a square root that is right there. So I'm going to go halfway, which would be 3.5. Now, you can use perfect squares to find those that aren't perfect squares by using a range. So we're looking for a range. We're not going to get exact because it's not perfect. So we've got to get a range in order to find the answer. So we're going to be trying to find a range that's going to be between, on this one, it's got to be between the 3 and the 4. Now, when we do the math on that, when you have your calculators with you, you would know that 3 squared is 9 and 4 squared is 16. So you have to look within that range for the closest decimal. Okay? So that's why I came up with 3.5. Now I'm going to add my 6 to that, and that's going to give me 9.5. So I'm going to put 9.5 right here. So this would really be 9.5 once I'm done with it. Okay? Because I got to add that 6 to it. 3.5 plus the 6 is 9.5. 3.5 was my range. So I'm done with this side. Now I'm going to go over here. Let's look over here. 12 plus the square root of 6. Well, what's the square root of 6? 6 is not a perfect square. There is no perfect square for the square root of 6. Okay? So I've got to see, where would 6 fall? Here's 2. Here's 3. Here's 4. Where would 6 be?
In between 2 and 3.
In between 2 and 3. Okay? In between 2 and 3. The square root of 6 would fall right here between 4 and 9. So just pretend that the square root of 6 would be right in there. Okay? Between the 4 and the 9. Now I've got to find a range. I've got to find a range. I know it's going to be between 2 and 3. So it's in the middle. So I would say 2.5. But don't always guarantee that that will be the answer. It's best to be able to solve it by working it out. And I'll show you how to do that using your calculators. But the range would probably be right in here. So we're going to say between 2 and 3. So I came up with over here. So that's going to give me 12 plus the square root of 6, which is 2.5. And that's going to give me 14.5 when I add 12 plus 2.5. So now I have 9.5 and I have 14.5 on this side. So which one is greater? Remember when you were in 3rd grade, they used to say the crocodile always eats up the largest number? So 14.5 would be greater, and that's why I chose to write it this way. So that's just going to give you an idea without using a number line how we're doing that. And this can help us list a mix of rational and irrational numbers from least to greatest. Please go back and look over this in your notes. Now I want to do it by placing them on a number line, but I still want to do it from least to greatest. It says place in order from least to greatest. Here we go. You got the square root of, we need to know the square root of 12. We have 7, which is a whole number. We have pi plus 2, and we have 25, square root of 25. So we need to order these from the least to the greatest. We need to order these from the least to the greatest. So let's take a look at our perfect squares. These are our perfect squares. Square root of 1 is 1. Square root of 4, 2. Square root of 9, 3. Square root of 16, 4. Square root of 25, 5. Square root of 36, 6. Square root of 49, 7. Square root of 64, 8. Square root of 81, 9. Perfect squares. They're just perfect. Now, you notice this is an imperfect square and this is an imperfect square. So, let's move down here. I rewrote them.
Ms. Heath, if I may make a suggestion?
Yes.
Square root of 25 is a perfect square because it's in the pattern.
Thank you. So, this right here is a perfect square, which would be what?
5.
5. Thank you. Square root of 25 is 5. This is a perfect square. This is not a perfect square.
Yes, ma'am.
Thank you. This right here is just a whole number, right?
Yes, ma'am.
Thank you. I like the way you're listening and catching that. Awesome. Okay, now, take a look at 12. We know that 12 is not a perfect square. So we've got to find how can we get close enough? We've got to get close enough to finding what? What are we looking for on this one, young man? What are we looking for?
The closest to the square root of 12 without going over.
We're trying to find the closest to the square root of 12 without going over. Say that again. We're trying to get the closest that we can get to the square root of 12 without going over. So we know we're going to go back and look right here. So move with me right here. If you would move back with me right here. All right. We know that the square root of 4 is 2. Square root of 9 is 3. Where would 12 fit? Here's 4, here's 9, here's 16.
Between 9 and 16?
That's right. That 12 is going to fit right in there. Between 9 and 16. Right in the middle. So therefore, what two numbers am I looking at?
3 and 4.
3 and 4. 3 and 4. So what's between 3 and 4? How close would that be? Would you say 3.5?
Yes, ma'am.
Yes. 3.5, again, that is a close range. That is a close range between that. So we're going to take that and we're going to just hold on to that thought. We're going to keep the 7 because it's a whole number. There's nothing we need to do with that. Remember, we're ordering these. Then we've got 3.14 plus 2. We know pi is 3.14. So we need to add, we've got 3.14. We're going to add 2 to it. 3.14 plus 2 is going to give us what?
5.14.
5.14. When you put that in your calculator, 3.14 plus 2 is going to give you 5.14.
Miss Eve?
Yes.
Didn't you say pi was an irrational number?
Yes, I did. Explain that to us.
Well, pi in a sense is being used in a formulaic expression. And when pi is being used in a formulaic expression, it's broken down to 3.14.
Awesome. 3.14. So instead of me saying 3.14, I need to say 3.14 on these. It will make it a whole lot easier when we plot this on the number line. Thank you. Now, when we get here, we've got to figure out what's needed and what's left because we know the square root of 25 is 5. So now let's plot them. We've got 12. We said that that's going to be 3.5. Okay, and now we need to plot these on our number line. Notice that here is my 0. These are my integers. Remember, integers, even if they are on the right side, they're still called integers. The negative numbers are integers also. But where would we put the 12? We said 12 is 3.5, so 3.5 would fall just between the 3 and the 4. So we're going to put the square root of 12 here. The square root of 12 is between the 3 and the 4. So we got, we put 12 here. 25, square root of 25 is 5. So that's going to be, this is the smallest. As you can see, this is the smallest. Right now, this is the smallest. Okay? So the square root of 25 is 5. So I'm going to take my marker and I'm going to put my dot here. And I plotted it. I plotted the square root of 12 here. I plotted the square root of 25 here. And then I wrote square root of 25 is 5. Now, 3.14 plus 2, we said is 3.14 plus 2 is 5.14. Okay? And so I'm going to place the 5.14 between 5 and 6. So, hope you can see that, but that's my pi plus 2. And then all we have left is 7 because we've used everything. We used the 12. We've placed the 7 on the line. We've placed the pi. And we've placed the 25. So, I've just showed you how to place in order from least to the greatest. So, this is the answer right here. Okay? This was the original one. And then right here is where I put them in order. We'll do one more, and then I'll leave you to work by yourself. We've got pi squared, the number 9, square root of 74, square root of 89. Pi squared. If you have your calculator, you're going to take 3.14. Squared means times itself. 3.14 times 3.14 is 9.86 when I multiply these. And the reason why I multiplied is because 3.14 times 2, and when I multiply that, I'm going to get 9.86. So I'm going to move over here, 9. I'm just going to bring that 9 on down. Here's 74. Square root of 74. I can't think of any two numbers, if I multiply them together, that's going to give me 74. But I need to get as close as I can. So let me think. What can I do on that one? So let me think. 64. If you have your chart with you on your square root chart, you can look up here. Remember, we're trying to get to 74. The closest I see that we can get is between 64 and 81, which is 8 and 9. So that 71 is probably going to fall right in there. Okay? 74 would fall right between there. So you could say, I would say 8, that's 9. I would say a halfway marker could be 8.6. I will show you later how I got 8.6 and not 8.5. If you use your calculator, you will see what I'm doing. Anybody have any suggestions as to why I chose 8.6?
Miss Eve, didn't you write it out right here under the square root of 74?
I did, but why did I choose 8.6?
Because that was the closest estimate to 74 without going over.
That's the closest estimate without going over. And then I even broke, good, you are doing good with this. So what I did, I even did the math for you to show you how I got 73. I broke it down for you right here, why I chose 74. Why I chose 8.6, because when I multiplied 8.6 times 8.6, come in close to the person that's videotaping for me if you get closer. When I multiplied 8.6 times 8.6, I got 73.96. And that's pretty close, you guys, to 74. That's pretty close. That's really close. 73 is going around to 74. So that's why I chose 8.6. Now, let's take about the square root of 89. Where would that fall? The square root of 89. Anybody got any ideas? Okay, the square root of 89. Anybody got any ideas? Square root of 89 would fall between what?
8 and 9.
Okay, 89 is probably going to be over here, right?
9 and 10.
Oh, that's right. It would fall this way, going that way. So it's got to fall between 9 and 10. Here's 81. Okay, so let's see. It has to be between 9 and 10, which is the square root of 100, which is 10. So let's try it. Let's say 9.4. You could play with it with your calculator, but I gave it 9.4. So 9.4 times itself gave me 88.36. 88.36. That's pretty close to me to 89. It's close enough. Okay, so that's the closest I can get. So why is my answer 9.4? Where did that come from?
It's an estimate because you still have to square root the 89.
That's right. You still got to find the square root of the 89, which we said it was 88.36. And the square root of 89 is what? 9.4.
Wouldn't that be approximately 9.4?
And that's right. It's an approximation because it's not a perfect square. Awesome. Woo! Y'all are doing so good. That's still considered an approximation because that's the closest you can get. Now, last thing I'm going to do is plug them in on my number line. Can you get closer? Can you see that? So I'm going to plug it in on my number line. Here we go. We had the square root of 74. That's the smallest. The square root of 74, we said, is 8.6. So can you see that's the square? There's 8.6 is going to fall right here. 74 is the smallest. Then 9 is going to fall right here after the 8.5. There's your 9. Why did we put 9 there? 9 is just what? Just your regular whole number. Now, what about the square root of 89? We said the square root of 89, once we worked it through, that gave us 9.4. And 9.4 would fall right there, right in the front. So that's why we got square root of 74, 9, 89. Then what about pi? Pi is what?
9.86.
9.86. There it is right there. 9.86 for those that can't see it. 9.86. So that's why I wrote that pi symbol right there. There it is right there. And I really put them on the top too so you can see them. Hope everybody can see that. I know it's kind of busy, but if you go back and look over it, you should be able to figure it out. Did I miss anything?
No, ma'am.
I don't think I did. Please, please, please go back and review this. And I think you all will really appreciate these notes and this PowerPoint because it's going to help you a lot. See you in a few minutes. Bye.